Wiring method for transformer capacity testing. First of all, we equip 3 clip wires of yellow, green and red with the instrument. Yellow is the same. Crude connection current. Fine connection voltage. We are connected to the capacity test circuit. This time it's the current here, voltage here. Pay attention and don't connect it wrongly. Then connect the wire to the ground. Ground wire. The wires on the instrument are connected. This line has not been connected. It does not need to be connected. For example, if there is 0 on the high voltage side, you can use a wire to connect it yourself. Generally, this wire does not need to be connected, so we do not give this wire. The wiring on the instrument has been connected. Let's talk about the wiring on the transformer. Same here. Yellow, green and red. 3 clips. Yellow is connected to A on the high voltage side. Green connects to B on the high voltage side. Red is connected to C on the high voltage side. These 3 clips are connected to the high voltage side of the transformer. Just short connect the low voltage side ABC with short pliers. Just like, it is the same as the wiring method for the load experiment. This black plier cable will be given to you. These 3 pliers can be connected casually when picking up, regardless of ABC, because they are all connected. Just clip the 3 pliers on the 3 pillars of the transformer. Connect it however you want. It works anyway. Just make them in a line. After connecting the wire, we enter the capacity test interface. Same here. The first is the number of the transformer. The second is the type of transformer, oil or dry. We choose accordingly. The same goes for the third one, winding connection. Fewer options on the capacity test settings page. Type of iron core. Choose whether you are an electrical steel belt or an amorphous alloy according to the actual material. Rated voltage on the high voltage side. Fill in according to nameplate. Transformer short circuit impedance percentage. It is also filled in according to the display of the nameplate. Ambient temperature. Finally, the temperature of the transformer under normal operation. Under normal operation, the temperature of the oil transformer will reach 75 degrees. At this time 75, it is most accurate to measure its load, but under normal circumstances, our measurements are all in the state of power failure. It's not running inside. Its temperature will definitely not reach 75. So we're going to fill in the temperature. When we measured it on site, it was equivalent to a power outage in the transformer, and its temperature was 20 degrees. In the power off state, the temperature of the transformer is actually the same as ambient temperature. With these 2 temperatures, convert this value to 75. It is equivalent to 75 degrees as the standard, but it was 20 degrees when we measured it. To convert this difference to the value at 75 degrees, the value at 75 is accurate. After setting up, let's click OK directly. Then wait a few seconds, because at this time, we can measure the voltage, but no tested object was connected. It has no current. And in a few seconds, test finished. You can know the voltage and current. Power factor is power. Model of transformer. This is the measured capacity. Transformers say 100. It was measured to be 99.9. Then this is the judgment. That is to say, based on your measured capacity, judge its value. Because its measured value is definitely a little different from the nameplate mark. For example, if you see it as 30 now, the actual measurement may be 29.8. Or 29.9, it must have a little difference. Because there is no load now. So this value is negative. The internal procedure of our instrument starts from 30 kV capacity minimum, because there is no load now, but it can't be judged to be 0, it fills in the smallest value. S15 is the transformer model written by the system by default. Measured loss. This is the national standard value. For transformers of different capacities, national standards specify a loss value. Is a standard. 1 is the measured loss. 1 is the corrected loss. This is the corrected loss. We just had 2 temperatures. A 20 degree, a 75. 1 is measured at 20 degrees actual temperature. 1 is converted to value at 75 degrees. This is 75 degrees. This is the energy efficiency rating Chinese standard. Other countries need to refer to local conditions. China is now divided into 3 levels. 1, 2, 3. There are 3 efficiency levels. This is similar to the energy efficiency rating labels on appliances, such as refrigerators. Now, transformers also have energy efficiency class standards. Transformers are divided by the material of the iron core, according to the electrical steel belt and amorphous. Amorphous is a better material. It may be first level or second level. The electrical steel belt may be level 3. Energy efficiency is relatively high. Can judge the energy efficiency more intuitively by the level. The experiment is over. Click Save. Print. No load, load, capacity. All 3 tests are explained. Data query. Here is a setting. Set time. Then you can choose. When testing load, there are 2 test methods. National Standard Formula Method and Temperature Calculation Method, in the absence of a DC resistance tester to measure resistance. So we chose this thermometer algorithm. If you can measure the DC resistance, you can use the National Standard Formula Method. Fill in the DC current and temperature when measure DC resistance. This is the connection method inside our instrument. The comprehensive test bench has WOmeter method and 3-meter method. Our model is desktop model. It only need default process of 3-meter method. Only when do no load and load test, regulators are needed. The capacity test does not require a voltage regulator, but only uses the lithium battery inside the instrument to measure. This is the end. You can directly remove the wires and then shut down. It's a very simple device, simple wiring, simple operation.
Thanks for watching the tutorial video prepared by HD Yoga Manufacturing.